One. Hello, everyone. Hi, everyone. Welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we're going to have one of our students, Romulo, who has completed one of our courses. This is ROS Navigation in 5 days. So we're gonna see how he controls a real robot and then perform autonomous navigation on that robot. So, um, welcome, Romulo. How are you?
Hello, everyone. I'm fine. Hi, Rodrigo.
Hello, hello.
Thank you.
I'm excited to see what you've done with your presentation. So, whenever you're ready, let's go ahead and get started. You can share your screen and just show us what you've done.
Okay, now I'm sharing. Can you see the screen?
Give me a second. Let me see. Yes, I can see your Rust checked.
So, okay. Um, for everyone, here I'm going to present ROS Navigation in five days. So basically, we're going to jump to the last part where we are starting the navigation. So let me launch. First of all, let me into the key. So, so okay. So let me launch the launch file so everything can be stated. Turtlebot navigation navigation. So here I'm launching RBs, uh, SLAM, MCL, and the map. So we are gonna see here in RBs. Yeah, here
Mm-hmm.
we already have the map because I'm launching it from this launch file. Okay, so let's open the configurations we need for so we can see the covered view for the navigation.
All right.
Here's map. Okay, so sometimes I have okay. It take a little bit
Yeah, it takes
to
a while.
launch everything. So basically, I here we have the local cost map is not ready yet, but we have the global cost map. And first of all, we have to estimate the post of the robot. So let me try to do it. We robot is around here. Yeah,
Oh,
so we
nice.
are okay. So we have two options here. We can send a goal to the navigation stack and the move base node, so the robot can go uh, any position in this map where you specify. For example, here, here the robot start moving at the point we sent it.
Oh, I see. What do you mean by the local cost map's not ready yet? I heard you
Local
mention
cost
that.
map is like let me
Yeah, I see it
explain
right there. There's a little
so
bit of
local
confusion, I think.
local cost map is like the
So,
how the robot can see the obstacle in real time.
right. Let me show you something. When if you go to the global cost map on the left side panel, you can
Yes.
change that to a
Okay.
different color, so it's not that confusing. In one of those, it
Okay.
says,
Let me put this in a bigger
yeah, yeah, yeah.
so we can.
That's the global plan.
No,
So we
this is
want
the
the
global
global
plan.
cost map. Yeah.
Yeah, here, Cosmos and raw. Yeah.
I would do the other one, map.
Sorry.
I would do the other one, the other option called map.
Oh, okay, okay, okay. Let
Just
me
I saw
just.
you have your configuration real nice, so I figured this really clearly tells you that the global
Yes,
from the local. Great, awesome.
it's a
Well,
clear view. So, in order to also complete the course,
uh
so
huh.
we have to make a service where we can like send specified points we already saved in
Uh
the
huh.
map. Like if you want to send the robot always to this point, you get the positions, or at this point, or at this point, you get the position and you save it, and you can send these commands to the mood base node or the navigation stack, so the robot can go without you have without the
Well, using that.
we are using this function in RPs. So let's try to use uh, this service. I name it uh, label servers, label service.
Uh huh.
So we can send service label service. So we can
So
here my three spots are named as corner one, corner two, and pedestrian.
okay.
So in order to go to the corner two, which is this one here,
Uh huh.
or the pedestrian here, we just need to type it. So corner, for example, if I send the robot to the corner two, we're gonna have a little bit some problems in the track because of the obstacle avoidance. So the robot start mapping from one side on another and start circulating. But let's go in step for the pedestrian
Okay.
spot. So it's gonna be okay. Here. Okay, I have the map like this. Okay.
I think. Oh, that's great. But I think you just sent them another goal. Oh no, you're fine. Yes. See, it's rotating because you accidentally sent one goal. I think.
Now here starts rotating because sometimes it gets so confusing because I have not tuned the configuration files of the
Yeah, the
navigation
map is a little
properly. So
different
because
this
you
time.
need so much time
Uh
to
huh.
you perfection this. So let's try with another command. So let me wait a minute. I ended up the wrong node.
Uh huh. I think it was localized
Yes,
like upside down in that moment. So
yes,
maybe I
I
can
am.
run over there and move the obstacles to match your global map. But let's see.
No, I think there's no problem because it must to avoid avoidance
Uh
the
huh.
obstacle with the global local cosmos. But let me please try this again. I'm
See, see.
sorry. Standard configurations. This graph. I must do. We are like here in this pose. Select.
Mm-hmm.
um, Okay. So let me just put it a little bit far from those obstacles and change all the time. One more time. Mm, the lower cosmos so we can see it better. Not as I well, the local cosmos is not ready yet, but it would be. It must be.
There it
Okay,
is.
there is. In order to what I say. So, one more thing I did say before is that if the robot did not reach the point you specify or you send the goal, when you send the goal, the service must to show this error that
Uh
the
huh.
navigation you send it was fake. So let me try one more time. Pedestrian. I mean, yes, yes. Um, pedestrian.
So which
Let me see.
pedestrian crossing is it going to? The one that's really close to it, or the other? Oh,
Yes,
I see. I see the
it's
path.
going like this side.
So you can see there. It's
There is
I'm wondering why
like
it's going backwards so often. Is that a
like
recovery?
yeah. I think that in the configuration files I made some change, and because and the one with I was trying before was giving me some errors, so the navigation didn't work. So what I did was to modify it until I got the robot to reach the position. Um,
So do
how
you
can I
mean
say
that
it?
it's going backwards without navigation, so it might
What I
crash?
tried to do was to make the robot reach the position. Um, how can I say? And no matter if it take too much time, like how can I say it?
Right, there won't be a
Like
timeout.
yes, so here he reached the robot reached the position I wanted,
Yeah.
but it takes some time
Did you notice
because
that it was spinning in circles?
sorry.
So I'm gonna just make comments. It was spinning around, kind of like trying to get to that final position. That's maybe because your goal tolerance is too low. And in here,
Like I said, um, this time the obstacle are in other position than before. The time I was trying and it worked to fine,
yeah,
but
no, it's working.
like
It's just a problem of uh,
of
maybe
the
it's
goal
gonna get
region, yes, but
unlocalized.
I don't know how can I say what I want to say. The thing is that in these files, let me show you here, where you configure the navigation parameters,
Uh huh.
you can change so the track you can make it far, nearest, or even you can make the road to change the directions, where to go, how
Yes.
far of the obstacle you can be. So I was trying to modify it to make it the work,
Uh huh.
but this time it's not making it. I don't know
So
why.
yeah, it's not finding a path. So if you zoom into the RVIS, we can actually see a little bit more what it's trying to do. Maybe we don't have a local path in. See, there you go. So
That's one thing I did not understand when I was doing my course is why the global plan is trying to go through the obstacle.
it
In fact,
shouldn't.
of going this way.
What that tells me is that the path is not going all the way over there. There's an issue there, so it's never gonna make it. Because if you send a navigation goal, so all right, so if you send a
Okay.
navigation goal to that corner right now, you'll see the
Yes, it's
whole
gonna work.
plan. No, no, do it far enough. Do a far one.
And like this point, or
Yes,
far here.
yes, like very far on the other side. We should see the whole plan. There it is, and you can see how the green one, that's the
Yes, the
global
global
path.
plan. The global plan.
And I think there's a problem with the global path because see, the local plan is updating really quick and it's following that global path. But if you yes, this is a parameter thing that
Yes.
you like sort of the goal here is to see that plan, that green line all the way to the place you clicked it because that tells me you have a parameter that's stopping it from going that far. Uh, so I think that's a great way to avoid those issues that is going backwards. That is the most strange thing to me, though, that it goes backwards. I'm not sure I really understood what you did there.
Like at this point, you can see it has the point in front of him, but it's going backward, like you say. I did not understand why,
We need to,
but
so yeah, yeah, that's interesting. So we would need to figure out if this is so this is a recovery behavior because MoveBase has a couple of recovery behaviors once it sort of gets stuck. And again, it'll get stuck more often if that global plan isn't like correct. You should see the whole path. Uh, but it will
Okay.
get there eventually because we saw that it's doing that.
In this case, it's going backward through the position, the first
Which
position.
which controller are you using? So there's a differential drive plugin, and there's also a
S is,
DWA.
is a differential drive.
Okay, see, because
Yeah,
I
in
think
this
it's a
case,
matter of
you
yeah,
can see the navigation was successfully.
yeah, yeah.
At,
So yes, basically, there's a couple of issues here. Uh, some are like sort of intrinsic to the environment where you're in. Namely, this map is really featureless, and it's hard for the robot for the AMCL to sort of always know where the robot is. That's why you see it jump a little bit, and that's why it's not aligned right now. So that can contribute for it to not reach. Another thing that I'm noticing is that thing I talked about, the global path. So yes, in that global cost map params, I'm sorry, maybe it's in the global planner,
global cosmos params here.
Navifn global planner. So that's the last one.
Navigation global planner here.
So in this one, I'm not sure where it might be,
I,
but
um,
something tells me that it is
must be from here.
something's missing here. That the path is not so it's not calculating the full path of the map for some reason, and that's another contributing factor. I can't remember right now, but I mean just giving you clear ideas. And another thing that I think might hurt is that I don't know if you agree with me. It seems like the robot is going a little too fast, right? And that means that the update frequency at which the global and local planner have to update has to be a lot quicker. You probably have a hertz parameter for your
Yes,
controllers.
here, let me show you. No, no. Global cosmos parameters. Yep.
Update frequency. See, this is pretty low. This is 5 hertz. So that means it's going to update 5 times a second. And it's going
So
pretty quick. So by the
I, I
time,
use I use these numbers in the update frequencies because in the real road simulation, I was having trouble with a higher frequencies.
yes, because the free, so it's sort of a balance you have to strike. Because if you say you put it at 50 hertz or something, you're going to get a message that, oh, the loop didn't catch up in time because it's the controller's trying to go too fast to
Mhm.
replan and everything. So my guess here is that another thing that is happening is that this global path, this global plan, I'm sorry, the green line that you when you click a goal, it's
Mhm.
it's having trouble because the update happens when the robot has already moved too much, right? So there's it's a big move. So that may be another reason. But can we just try one more, just for curiosity, one more goal, just with the Arvis right there,
Okay.
with
With
clicking on like the
two
opposite corner, let's
Navico
say.
hero or forest.
I would do the opposite corner, but that's all right. See, yes, definitely. So the robot is going forward here, and it won't replan because it's following the plan, right? So when it gets there, it, when it gets to that point, it's like, oh, there's more obstacles, so it's gonna replan. You also have a parameter of how many times you want to replan, and if that gets out of it, you're gonna have a navigation not successful. And so here you can see it's also getting unlocalized. So the lighter doesn't match up with um, the map again because this is like sort of a hard map. But now it's going back and forth, and it seems like it's getting worse as you go along. So that's gonna make it even less likely for the goal to be reached. If you were to click here, now it's kind of sort of gonna. Now it thinks it made it almost. But
No, no, no.
if you tell it the actual localization now, so while this is running, set the localization where it actually is because it's not there anymore, right? It thinks
Yes.
it's somewhere else
Let
now.
me let me try to. Okay. Let me.
I don't actually know precisely, but
Yes. Is this going this way? No,
so it's a little
no, no, no.
flipped. But
I have the plan. This case is this way.
well, it's looking to one side. So um, you did it facing up.
Okay.
So like to the left, yeah, like that. You see, not kind of. And if you go to the, there you go. But that service is still being called.
This one.
Oh,
No,
you didn't press enter. Okay.
no.
Yes.
Uh,
So I think this is like a combination of things. It doesn't mean what you've done is wrong. It means it needs more
let
work.
it's strange for me because before I wanted to presentate the course,
Uh huh.
I tried very time and it worked fine. So, in a better way, not perfectly, but in a better way than today.
No, I mean it's
Uh,
working really well, and with what I'm seeing, it makes sense that sometimes it'll make it quickly. Like you can't really know when it's gonna happen. See, right now it's still spinning around because just till now it found the goal. You can see it right there, actually. Yes. Uh, let's just try one more time to the furthest spot you.
through the service or
Yeah,
with the
through the service.
navigation
Let's do
go?
it through the service. Yeah, like the furthest one from here. I don't know which one it is for you.
The corner one should be the opposite, like here.
Yeah, yeah. And then let's go to the other terminal, the one that's telling us things. See how it's saying got new plan, got new plan, got new plan. I think
So every
that's.
time I was trying to, I was in the course, I got these messages. I thought it was normal.
But see, you either have a DWA planner. That tells me something else too. The DWA
This is new.
might be.
It sometimes it showed the W playing file, but not at much. This much. This is new.
No, and this is fine, the DWA. So that's related with the differential drive robots, which this is a differential drive robot. There's another one called TEB, which is for car-like movements, which actually was my first guess because it was sort of backing up, and I haven't really seen a differential robot do this with move base. Instead of doing that, usually what differential drive robots do, they just spin on themselves until they can have that
Until they
path.
can have the plan.
And
That's
since that
this.
path is like a straight shot every time, of course, it's gonna have to like move back and replan. So everything that you're launching here is working. It's just a matter of fine tuning
Yes.
that I think will make it go to the spots every time. But I think this is very, very good, and it shows a good understanding of what you're doing. Um, let me ask you, because I think we're sorry, we turned this presentation sort of into a conversation, but that's sort of the idea of these things. So, do you have anything more that you want to show us?
Um.
Because if not, I have a couple of questions.
No. Yeah. This is like everything I must do, but
Great, great. So let me ask you first, because we didn't go into it that much, and we don't need to. But I'm just curious, how did you save those positions? Uh, how were you able to record that position, let's say pedestrian, and then call the service with that? Can you just tell us in
Okay.
2 minutes how you did that?
Uh, um, I make this script.
Mm-hmm.
So in this script, I'm reading the MCL post. Let
Right.
me
Uh-huh.
see. Let me see if I can. No, no, no. This is not. I'm wrong. I'm wrong. I'm wrong. This.
It
Where
probably
it
would
is?
be in.
Spot file.
Mm,
Here. Here it is. I'm really subscribing to the MCL post, so I can get the position every time I'm in the map everywhere.
yeah.
So when I am in the position I want to save, I just call this service, and this service save the position in a script in a text file,
Uh-huh.
which is localization here. Here it is
Ah, there it is.
in this
Yes.
way.
So let me
So
make a comment in this real quick. Sorry to interrupt. So,
I also made manually.
uh-huh, like you said, you're subscribing to the AMCL post. Now,
Yes.
if you're not very well localized, those positions are going to be like not exactly the ones you're on because the robot thinks it's a little shifted. So that whole process creates sort of a, how would I say, like a domino effect that
Okay.
will eventually lead to the robot not reaching its pose. But yes, that's just what I wanted to know. And yeah, the thing that is leaving me a little bit confused is the reason why that global path it shows up like that. But let me tell you, if you figure that little detail out, I am 90% sure that your robot would arrive every time because it didn't look like it was a local planning thing, but it rather um, a global planner thing. Um, and I don't know. What do you think? What do you think is the reason why uh, it still needs a little bit of work for precision wise?
Um, like you say, first of all, I think the robot is going too fast.
Mm,
So um, the thing is, I thought I have the difference in the simulation and the real road,
yeah.
so I kind of have to try to keep tuning these parameters.
Right.
But I think this is a great point that the velocity is the speed of the robot is too high, and also I was not sure, but now with your comments, uh, I think I get the strange point. Like I did not understand why the global planner was like this is like a meter far
Uh
from the
huh.
robot. And in the when I was trying in the course, I could see that the global planner was at the point like you said, but I really was not that sure.
Uh
And
huh. That would be a good thing
but in
to
the
compare. Yes.
generally, I think it's like this is a parameter problem because
Yeah,
uh,
I agree.
I was trying two different files, combinations, parameters. I read a lot of the documentation, changes a lot, but I think it requires more time, like
Yeah.
to get a better performance.
All right, Romulo. So I think we are out of time. Let me tell you, congratulations. This is a solid project, and now you have the basics, so you can go forward and to investigate why these things might be happening, how to fix them. For example, I can tell you this much: if you reduce the velocity in half, you'll increase the successful attempts like a significant amount. And I know why you probably did that is because in the simulation it goes real slow, huh? So you want
Yeah,
to go a little
that's what.
quicker, and here it's like whoa, it goes a little quick. But of course, there's a little bit of a difference there. Uh, but yes, that for example, that would be one, and for example, decreasing the velocity and increasing, let's say, to 12 hertz, the global plan. frequency.
How much?
Usually it's like
How,
20 hertz. I would say that's the normal, like for a good performance. But since it's a little robot, I'd say uh, like 12
for
hertz is all
both,
right.
or for update
I
frequencies
would say
just?
both and see how it works out. You know,
Okay, okay, I will
and
try.
but yeah, other than that, that's the biggest thing that I saw is that global path thing that I don't really understand why it was happening, and I'm sure that is the uh, sort of fix for these strange things you were having. But anyways, I want to say congratulations. Really clear, really nice to see everything organized like this. It means you practiced and you tried this a bunch of times before. So I want to just congratulate you.
Thank you.
All right, guys. Do you mind stopping sharing your screen just so I can say bye here to everyone?
Okay.
All right. So everyone, to everyone else that's watching, this is what you can do if you take our ROS navigation course in 5 days. So I invite everyone to do what Romulo did to finish your online course and then test those learnings in a real environment like we have with our Turtlebot. So again, Romulo, congratulations, and we'll see you again soon.
Thank you very much, Rodrigo.
All right, guys. Bye bye.